In this little segment here, we're going to learn how to solve logarithmic equations. And I'll just read through this little segment here. Like exponents, when solving logarithmic equations, simplify any expressions using log laws first, then rewrite each side as a single logarithmic base, so we're pushing everything onto one side. Once that's done, you equate the powers and then you solve for the unknown. And then you check your solution so it makes sense, just making sure that the value of m has to be greater than 0 when it's inside a logarithm. So we're going to look at example 4a now. What I do want to teach you is that we can re-express this as 5 to the power of 3. Now, in order for us to do that, we need to come to understand that the opposite of a logarithm is an exponential. And what I like to do is this slide method, where 5 is, we say log base 5 of x is equal to 3. So log base 5, since it's a base of 5, when we take it over to the other side of the equal sign, the 5 is still considered to be the base. And so the 3 will be pushed up into the power. So it becomes x to the power of 5. X equals 5 to the power of 3, which is 125. In part B here, we're going to have a look at here again. We're going to slide that log base 5, so the opposite of a log is an exponent. Everything inside that bracket there gets released. And we have 5, a base of 5, and this 2 on the right hand side becomes the power. So we continue on, simplify that. After this, it's quite straightforward in the sense that it becomes a linear equation. Something more involved here, we want to merge the logs so we consolidate it onto one side. We notice here that there's a base of 2, and same base, if we're subtracting, we're going to divide everything inside the brackets. So we can merge these, and again at the front there's no coefficients or additional coefficients there. So we're going to go 2x plus 1 all divided by x minus 1. That equals to 4. Now since there's only one log left on the left hand side, we can move that base of 2 to the right hand side. So we end up with, I'll just put these arrows here at the front here so that we can see what steps are included. So everything inside the bracket gets released. The base of 2 moves to the right hand side, and that power of 4 gets pushed up. Just going to repeat everything on the left side here for a second. 2 to the power of 4 is 16. And I'm just going to move this up. And then we solve from here. So everything divided by x over 1, if we take it to the right hand side, it becomes a multiplication. So we have 16 times x minus 1. 2x plus 1 equals 2. Going to expand here. And from here, it's a linear question. So I'm going to add 16 to the left hand side and subtract 2x from the right hand side. 17 over 14 equals 2x. Okay, I might just shrink this section here so we can work on part D. Again, notice the same base, we're adding the logs together. We are this time going to multiply. So we have x minus 1 times x plus 1. Inside the bracket, it's equal to 1. Sorry, I'm just going to change that to a double dash arrow at the front, just so we can see how many steps we have. Might move this over for a second as well, just before we go about finishing it up, because we're going to need another column here. Since we've consolidated everything to one side, we can, I won't hit two birds with one stone here, but I do notice that this is a difference of perfect squares, but we're going to go 3 to the power of 1. Okay, so taking the log from the left hand side to the right hand side, it becomes an exponential. We know that difference of perfect squares here, we're going to end up with x squared minus 1, because x minus 1 times x plus 1 is going to equal to x squared minus the 1 there. If you can't remember, go back to the quadratics, see if you can find that difference of perfect squares rule, as it will be there. So we've taken across the minus 1 to the right hand side. X squared equals to positive 4. If we square root, then we need a plus minus. So x here is equal to plus minus 2. However, what we do need to check here is if we put in a negative number here, if our bracket is negative, then it won't check out, even if it's just for one of them, because we are looking at the entire equation here. So if we put in 2, like a positive 2, 2 minus 1, that's positive 1, that's fine. It's a positive number there, it's a positive 1. 2 plus 1 is 3, positive 3 is absolutely fine. However, if we put in a negative 2 now, negative 2 minus 1, that's negative 3. Inside the bracket here is a negative number. That fails the entire equation. So we do need to refine our answer to x is only equal to positive 2, since x minus 1 has to be greater than 0. Okay, otherwise it won't work.